Hello students, this is Mr. McAllen and we're almost done with all these videos. I'm looking forward to that. Um, but we have 14 and 15 here where these are basically optimization problems. Now, these problems, remember, there are a variety of ways to get through them, but the way we would like to see you do them is to try to come up with a function that you can then either use a graphing calculator or a table to help find the maximum value. So in the first one, Bob wants a fence in a rectangular garden. Um, and in his yard, and he has 68 feet of fencing to work with. Um, if the garden is to be x feet wide, express the area of the garden as a function of x. Then find the dimensions that maximize the area. So let's first just talk about fencing. We have 68 feet, and we're going to make a rectangle with it. And that's a really good rectangle. Let me just use my drawing tool here, so that we're not like living in the Stone Ages. And well, we're definitely not living in the Stone Ages. We're making a video on the computer with tablet, so it's far from the Stone Ages. So I guess I'm being hyperbolic with my statement. But anyway, we want one side to be x, and the perimeter, and that means the other side's going to be x, and the perimeter can add up to 68. So normally people would put y here for both and say, perimeter equals 2x plus 2y. And then you say, okay, well, that's 68 equals 2x plus 2y. We would really like you to write this as a function of x. So look at how nice and easy this is. We just have, if you solve for y as a function of x, you're going to get your answer. So, by making that y and then solving for y as a function of x, so I'll solve for y. There's 68 minus 2x, and we divide by 2. Y equals 34 minus x. So that is my function for y. Now I can use that because I know my area is equal to x times y. I can plug that in, and I have this nice equation, x times the y function, 34 minus x. Now my area equation is simple. It's 34 minus 34x minus x squared. That is the equation that you need to use to find the maximum area. So you can do things a variety of ways. You can graph x or table x opposed to area as a function of x and plug in values. You can put on your graphing calculator y1 equals 34x minus x squared and plot it and find the max. So what I would do is I would probably either plug in values or use my graphing calculator. I could also use calculus to find that, but this is pre-calculus, so we don't want to do that right here. But your final answer, when you graph this and you plot it, you should see an upside down parabola, and the maximum value when you graph it or when you use it on a table will be found at x equals 17 for this problem. So hopefully you have success in working with that. And I want to try to get the last optimization problem in because Sue wants to make a rectangular garden on her property. She has a little bit more money, or, so she has 78 meters for her fence. But there's a river that runs through her property. So she decides to increase the size of the garden by using the river as one side. So, here's the river. And here's the fencing that she's going to use. So again, this will be x, and this will be y. We're going to set up the same sort of equations. We know that the area, again, is still x times y, but the perimeter this time is 2x plus y. So when we solve for our y as a function of x equation, 78 is the perimeter, 2x plus y, and we solve for y, we get 78 minus 2x. We're going to use that in the area equation. Area equals x times 78 minus 2x. And we're going to solve that or simplify that. We have 78x minus 2x squared. Again, you can put that on a table and you can go through all the values and find out where your maximum is. You can draw a graph where you plot, you know, area against the x value. You should find that when you graph it on the graphing calculator, you're going to get a maximum value at, I'm just going to calculate here, 70. At 19, x should equal 19.5 is where you're going to get your maximum value. Let me just go to the graphing calculator and check that real quick. I'm looking at the time. I have enough time. I'm going to use a graphing calculator, show you how to do that real quick, remind you of the steps. So when I bring up the graphing calculator, I'm going to put in the function for area, 78x minus 2x squared. Graphing calculator is a little slow today. Okay, so I'm going to put in y equals, and I'll clear out the function, and I'll put in 78x minus x squared. I'm going to go to a window that's appropriate. So remember, I have up to 78 feet of fence. So I want my x value to go up to 78 feet or meters or whatever, Sue's using. I think it's feet. And I'm going to make my x scale to go up in increments of 5, just so that it doesn't look so busy on the graph. And to be honest with you, I'm going to use probably, I'm going to say let's use like 500 as square footage. And that may not be enough to capture the max. So we'll have to look at the graph and make a decision once we see the graph. And I'm going to make my y scale go up in increments of 100. Well, that's not right. That looks like it's going up in increments of 0. I think that would give me an error. So then when we graph it, oh, look, it doesn't even fit. I can see it's parabolic, but I think I need much more area. So let me go back to my window and increase that. Maybe I'll go up to 5,000 for my y max. We'll graph that. Oh, I think we'll find the max here. So now, if I trace along the graph and plug in different values, like if I hit the trace button, I could just type in I'll type in 20, see where I'm at. Okay. Let me try. Oh, I put my equation in wrong. Holy smokes. That's got to be, I think that's got to be 2x squared. So let me change that. Don't make that mistake. Holy smokes. All right, so I'm going to insert 2. I think it's going to give me a different graph. Oh, there you go. So let's hit trace, and remember how I said it was going to be 19.5. Let's see if that was a lucky guess, or maybe I'm using magical calculus to help me with that. Oh, look at that. The maximum is at 19.5. Of course you can plug in values into the area function on a table, or you can graph it and use the, if you use the calculate menu to calculate a maximum, and the maximum will say, what's your left bound? And I'll say, well, 0. What's my right bound? Well, let me say 78. Find me what's my guess? I'm going to say, well, it's around 20, I guess. Let's see if it finds it. And there it is. It found it at like 19.4999997, which is 19.5. So hopefully this video has helped you refresh your memory on how to do these optimization problems. And I look forward to hearing your comments.